Welcome back. In this session, we will be looking at what is an integrated configuration, and we will be exploring information around how do we build an integrated configuration, what is the advantage of an integrated configuration, and so on. So before we actually go into integrated configuration, let's just recap a couple of things, right? What you see out here on the slide, the first slide picture that you see here is you have a sender adapter and you have a receiver adapter. And at the central component, you have the integration server, which in turn contains the advanced adapter engine or the adapter engine and the integration engine. So far in all the 4 exercises that we've looked at, a file-to-file scenario, our file to IDOC scenario, our SOAP to RFC scenario, and our HTTP to SOAP scenario, all the messages, all the interfaces were processed, the messages were processed through this route. What do we mean by that? Our sender adapter would pick up the message. The sender adapter runs on the advanced adapter engine, so the file adapter, the Java, the IDOC adapter, the SOAP adapter, the HTTP adapter, all of them were running on the adapter engine. So the sender, the message would be picked up by the adapter engine, and then the message would be forwarded to the integration engine, which in turn would do all the processing or would execute the pipeline of PI. So if you remember the pipeline of PI, it was receiver determination, message splitting, interface determination, or mapping execution, and things like that, right? So the pipeline was executed in the integration engine, and that is exactly what you used to see when you were doing your monitoring in SXMB Moni. For example, in the adapter engine, you would do the communication channel monitoring because the adapters used to run in the Java side in the adapter engine, and then we would switch over to the SXMB Moni, which you would run on the ABAP stack in the integration engine, because the message used to get processed in SXMB Moni, and finally the message through the adapter engine used to get delivered back to the receiver. Now, there were a lot of overheads. If you look at it, at the end of the day, for a file to get processed, there are a lot of overheads where PI was doing a lot of switches between its internal components. What that means, the sender adapter would send the message to the integration engine. That would mean one switch from the Java stack to the ABAP stack, and then again the integration engine would send it back to the adapter engine. That would mean one more switch, and then finally the message used to get delivered to the receiver. So this is what we used to call as a classical message processing or a classical configuration. So in the case of PI, so far the sender agreement, the receiver determination, the interface determination, and the receiver agreement objects that we created were what we used to call the classical processing of messages, where the message would pass both through the adapter engine and the integrated engine. Now, this architecture of PI evolved into one of the newer features of PI, where the SAP told, hey, why don't we do local message processing through the adapter engine, right? What do we mean by local message processing through the adapter engine? Now, if you look at this picture, the integration engine is not at all involved. The sender adapter picks up the file, but through the adapter engine does all the processing and pushes it out to the receiver. So the ability of the adapter engine to process the message locally within itself without having to send the message to the integration engine, as we saw in the classical processing, the ability of the adapter engine to do that, or the advanced adapter engine to do that, is what is called a local message processing within PI. And to configure an interface to use a local message processing in PI, you will not be creating, in the integration directory, you will not be creating a sender agreement, receiver determination, interface determination, and receiver agreement. Instead, to enable this local message processing in PI, you will create a new object type called integrated configuration. Okay, and this is what we are going to deal with in this, when we are going to build an integrated configuration. And when you build your integrated configuration, you will then realize that, hey, it's much more simpler, right? So we look at what the integrated configuration does and how does the integrated configuration do. Now, another evolution of PI, again, this if you look at the arrows, this was the first, XI 3.0, PI 7.0, and then from PI 7.1, this option of PI message processing was supported, And then from PI 7.31 onwards, you could install a Java only PI. Remember, we saw the difference between a Java only PI and a dual stack PI. This is nothing but a dual stack PI, right? You have an adapter engine and an integration engine. So from PI 7.31, all the functionalities that was available in the integration engine was made available in the Java stack, except for CC BPM, as a result of which you could start installing a Java only PI. So if you have a Java only PI or a PI that does not have an ABAP stack, the configuration that we saw so far, sender agreement, receiver determination, interface determination, and receiver agreement will not be supported, because in that case the message has to process through the ABAP stack of PI. So in that case, you would be using what we call as an integrated configuration. So integrated configuration is supported both on ABAP stack and Java stack, whereas the classical configuration, the sender agreement, receiver determination, interface determination, and receiver agreement is only supported on a dual stack installation of PI. Do not worry, we shall look at it. Okay. So how did this AAE get evolved? The first release of PI, again, the reason this information is being given is in a project you might end up being on PI 7.1. So you might have the ability to do integrated configuration, but that ability is very restricted, where you can only do some functionalities. Not all functionalities are supported. When I say basic mapping and basic routing, there are additional mapping functionalities and additional routing functionalities that we will see in the final sessions in the second half of this course. Were not supported. Then came PI 7.1 Enhancement Pack 1 or PI 7.11. There was no support, but again it was only partial support, not all the functionalities were supported. So till PI 7. Even when we went to PI 7.3, if you look at the term, most adapters are supported. There were still a few adapters that were not supported on PI 7.3, which were supported on the ABAP stack that was not supported. So again, there were certain restrictions around where PI 7.3 could be used, where a single stack PI could be used, and so on. But from PI 7.31 onwards, all the functionalities of PI is available, that was available on a dual stack was available on a single stack, excepting for one functionality, which is CC BPM. And remember, CC BPM is now replaced with NetWeaver BPM in a product called Process Orchestration. All right. So with that, let's move on to the next slide. What is the advantages of classic processing versus local processing? We've already touched upon this very quickly. In a classical processing, what will happen? Your message will go through the adapter engine and through the integration engine. Basically, your message gets processed through both the ABAP stack and the Java stack. And that means there are so many pipeline steps that get executed, as a result of which, these are all internal steps of PI, as a result of which there were certain performance issues. When you look at it in advanced adapter engine, when you're doing local processing via integrated configuration, the number of steps that are getting executed was reduced by SAP, as a result of which the message processing was much faster. Okay, so now we will look at building our first scenario using integrated configuration. What we will be doing is we will be building a file-to-file scenario, and we will be using integrated configuration instead of classical configuration. So from in an enterprise service repository perspective, we will continue to do what we were doing. Basically, we will define a data type, we will define a message type, we will define the service interfaces, we will define, sorry, this is missing here. Let me quickly add that. We will define message mapping and operation mapping. So the steps that you do in the enterprise service repository or in the ESR continues to remain the same. Where is the difference? The difference lies in the integration directory. In the integration directory, we would define a sender communication channel, a receiver communication channel, and we would end up defining a new object that is called an integrated configuration. Previously, we would have created a sender agreement, a receiver determination, an interface determination, and a receiver agreement. Now, instead of those 4 objects, we are going to only create one object, which we are going to call as an integrated configuration, and that would enable us to configure our interface. All right. So now I shall meet you back again within the PI server. All right. Let's go back to the PI server. All right, I'm going to my enterprise service repository. So the data type and the message type that we will be defining, the data type and the message type that we will be defining are going to be similar to the file-to-file scenario. So whatever file-to-file scenario that we build, the same data types and the same message types are going to be created. So the first thing that we will be doing, as always, is defining a namespace. So I'm going to call it http://file-to-file/integrated, I'll call it integrated configuration, or let's call it file-to-file ICO _00. Okay, the abbreviation for integrated configuration is ICO. So I'll put in a namespace here. Okay, I'll put in, let's put in an underscore here, file-to-file _ICO, and let's call it namespace for file-to-file scenario using integrated configuration. All right, so let's save this. Okay, so now our namespace has been created. Now, instead of, as I told, we will be using the same data type for both the source and the target structures that was defined in our file-to-file scenario. So instead of trying to recreate this data type, let's look at the option to copy data types, right, from one namespace to other. So what I'm going to do is, I'm going to my file-to-file scenario, I'm going to dt_src, my data type, and I'm saying copy object. So when I'm saying copy object, you can say, hey, what's the name, what is the new name of the object, and which namespace do you want it to be created. So I'm going to create it within the namespace file-to-file ICO. I say apply. So the new name is going to still be dt_source, but it's going to be within the namespace file-to-file ICO. So I go ahead and say copy. Now if you see, within my file-to-file ICO, the data type has been created, and the data type is having the namespace dt_src. So similarly, let's copy the data type _target. So copy object dt_target, change the namespace to our namespace file-to-file ICO, click apply, and then copy. Okay, so close all objects. With this, our data type has been created. Okay, now let's go ahead and create our message type. So right click, say new message type, empty_file to, so let's just call it empty_source, right? Create. And now what am I going to do? I'm going to drag my data type and put it, make sure it's on the help, on the handle button, and my data type, my message type is created. Save your message type. Now right click, new, make sure you are within the message type, say empty_target, TGT, right? And I'm going to say create. Now drag my dt_target into my hand symbol here, and my message type has been created. Save my message type. Okay, okie doke. So I'll close this. My data type is created, my message type is created. What is the next step? To create a service interface. So right click, interface object, service interface. Let's name it SIOA file-to-file. Okay, create. It's outbound, it is asynchronous, and the message type is empty_source. Drag it, make sure the black box is enabled, drop it, save your service interface. Next service interface is going to be SIIA file-to-file, right? Create. Now let's call it inbound, because this is going to be an inbound service interface, and let's drag and drop the message type here. Okay, and save your service interface. So my inbound is going to use by message type :_target. Close all my objects. All right. What's the next step? Let's look at our PPT. We are now going to create a service interface is being created. Now we're going to define an operation mapping and message mapping. So I'm going to go here, say new, select the mapping object, say mm_file-to-file. Right. This is my file-to-file. Now I'm going to go ahead, select my source message type as my source message, my target message type as my target message, and I'm going to go ahead and do my mapping. So my first name So let's go ahead to use my concat function. First name, last name goes to my name. Sorry, let's go ahead again one more time. First name, concat, first name, last name, right? This goes here and this goes here, and I'm saying aligning this, so my name has been mapped. Date of birth goes to date of birth, sex goes to sex, and qualifications I'll map it to details, align it here and make the context as employee details. Okay, and save. With this, our mapping has been completed. Let's go ahead and test the mapping. I go here, let's add 2 employees. Okay, John Doe, male, 1st Jan 1992. Let's say he's qualified in BE, he's an engineer. Let's duplicate subtree, and he's done his master MS. Then let's say Jane Doe, she's a female, 01 Jan, sorry, Feb 1992, and our qualifications is sports. Okay, and let's execute. Oh, there's a problem. Target field employee info incomplete. I did not map this. So drag employee details to employee info. Oops, sorry. Drag employee this to this. So employee info has now been mapped here. Let's go back to test, and now let's execute, and the mapping is completed. Okay. All right. Save. Let's copy this as our input XML. We need this message for our input XML. I'm going to save it as file to file ICO.xml. Okay. All right. Save your message mapping, and with that the next step is to define an operation mapping. Right click, new mapping objects, operation mapping, OM underscore file to file underscore 00. Okay, create. I'm going to drag my service interface here, outbound asynchronous service interface here, inbound asynchronous service interface goes here. I say read operations, and I say select my message mapping, and my mm file to file under my ICO namespace is available, and I save. So with this, my enterprise service repository work is done. So I'm right clicking, and I'm going to activate my changes. All my changes will get activated. All right, let's now go ahead with the configuration of the integration directory. So I'm going to my integration directory, and I'm saying folder create, and I'm going to call it file to file ICO 00. Okay, ICO stands for integrated configuration. I will just rename this folder, right click. So if you would like to rename your folder, right click on your folder, go to folder, rename. Okay, I'll say underscore, because it's getting very difficult to read otherwise, underscore ICO underscore 00. All right, excellent. Now let's go ahead and create what do we first create? A sender communication channel and a receiver communication channel. All right, so the same thing that we did in our file to file scenario, our communication channel, a sender communication channel will be created under BS file system 00, CC file to file underscore ICO underscore file underscore sender underscore 00. Okay, so now I go in here, I go to my adapter type, I make it as file. make sure it is of type sender, right? Now let's get our source directory. So I'm going here. Okay, I need not go there. I have my input here, and this is the directory from which I'm going to pick up my file. Okay. Now I'm going to call the input file as file to file ICO.xml. That was the name with which we had saved this file to file ICO.xml, the test file, right? Then go into processing and change the processing mode to delete mode. Save the same. Okay, my sender file adapter is created. Now let's create the receiver file adapter. So my receiver is going to be under BC underscore. I'm going to use the communication component BC file system 00. I'm not using the business system. Again, a reminder, business systems and business component, the differences. Business systems are created in the SLD. Business components are created directly in the integration directory. Business systems, you need not assign the service interfaces manually. In the case of business component, you need to assign the service interfaces manually to them. Okay, so let's go ahead, file to file underscore ICO underscore receiver underscore 00. I'm creating my receiver communication channel. Okay, then I go in here, file. Okay, I change the adapter type as receiver, and I say training. Let's look at the folder again. Sorry, I want to make sure I use the same folder. I don't want to create new folders. Okay, sorry, AL11 training. Okay, here I'm going to create, say, file to file ICO. So what's going to happen? This directory, does it exist in AL11? No, it does. Only a directory called file to file. But what's going to happen is this will get created because I've got a create target directory selected. Okay, I'll call the file as file to file ICO underscore dot XML. Okay, in the processing mode, previously we had used add timestamp. Now let's use add counter, and let's see what happens. Okay, add counter, as the name implies, is going to add a running number sequence to the file. We shall see what happens. Okay, there are other options. Add message ID will enable you to add with the message ID, but let's use the counter. Okay, so what were the other steps to be done? So the file sender channel has been defined, file receiver channel has been defined. Previously, you would have defined a sender agreement next, and then the receiver determination, interface determination, and receiver agreement. Now, what we are going to be doing is we are going to create a integrated configuration. So I'm going to this integrated configuration. So how do I create an integrated configuration? Right click, new. Now you see under collaboration agreement, you see this object called integrated configuration. Previously you would have created a service sender agreement. Now we are going to create an integrated configuration. So click on integrated configuration and see what information it is asking. It's asking who is the sender component. So BS file system 00 is the sender component. Who is the receiver interface, sender interface? The sender interface is going to be SIOA outbound file to file under our file to file ICO namespace. Okay, select it. So with that, and select this option and say create. Now when I say create, an object called integrated configuration has been created. Okay, it's asking me first what is the communication channel. It's asking me for a sender communication channel. Right, so I go here, use the selection help, and here is my sender communication channel. CC file to file ICO file sender 00. I say apply. Right, my sender communication channel is selected. Then there is this tab called receiver. In this receivers tab, what you do is you provide who is the receiver of this message. So if you remember, this was the information we used to provide in the sender agreement, right? In a sender agreement, you will give the sender system, sender interface namespace, and you will select the communication channel. So the same thing in the integrated configuration, in the inbound processing tab, you select the sender communication channel. Then you go to the receivers tab. This screen looks familiar, doesn't it? Yes. If you look here, it asks you type, it is nothing but an enhanced way of defining your receiver determination. Here you give the receiver of your message. Who is the receiver business system? It's the business component called BC file system underscore 00. Okay, go ahead and save your integrated configuration. There is a warning, no worries, error, we will fix that. Okay, let's close this. Now, before we go ahead and start defining the receiver interface, did we assign the service interface to the business component? No, we did not. So let's go ahead and assign, double click on the business component and assign the service interface here. So the service interface is going to be SIIA file. Let's just get the name from here. Sorry, I don't remember it. File to file. Okay. SIIA file to file. And say go. Okay, SIIA file to file ICO. Let's apply this, save this. Okay, so now I'm going back to my integrated configuration. Within my integrated configuration, in the receivers, I told who's the receiver of my message. Now let's go to the next tab, receiver interfaces. In the receivers interfaces, it's asking you for the mapping details here. So go ahead, use the selection help and select your operation mapping. Okay, so this is equivalent to the interface determination. If you remember, we would have created a new object called interface determination, and in your interface determination, you would have provided the mapping. You did not create a new object. You just go to a receiver interfaces tab and give the operation mapping here. Let's go to the next screen, outbound processing. Configuration for this interface, and it's asking you for a communication channel. Let's use the selection help again. It's showing me all my receiver channels. I select my CC file to file ICO receiver, apply. So this is equivalent to your receiver agreement. So what has happened at the end of the day is your inbound processing is equivalent to the sender agreement. Your receiver tab is equivalent to the receiver determination. Your receiver interfaces tab is equivalent to the interface determination, and your outbound processing is equivalent to the receiver agreement. So all the four objects that you used to create individually previously is now created in a single object called integrated configuration. So with this, you save. You need not do anything in these two settings. You leave them blank. With this, you save your integrated configuration and you are done. You are not creating four objects, but in the world of the integrated configuration, you're just creating one object. So go to your change list, right click, activate your changes. So I'm activating your changes, my changes, and my changes have been activated. Let's go ahead and test the scenario, right? So how am I going to test the scenario? I'm going to go ahead and upload my file using CG3Z. And here I'm going to say source file on the front end. Is file to file ICO.xml, and this gets uploaded onto my AL11 path again as file to file ICO.xml. Let's make sure that the file names are correct. It's file to file underscore, sorry, this is my receiver channel. I'm going to my sender channel, file to file ICO.xml, and let's upload the channel. Remember, allow. Okay, so next I go into AL11. I go one level up, oops, training, and you see my file to file ICO is available. Let's refresh. The file has been processed, picked up, disappeared, and now there's a new directory called file to file ICO, and you see the new output file has been created, file to file ICO. Remember, in the receiver file adapter we had given the option add counter, so it's now added the counter 001. So let's go ahead into SXMD Moni and see this message. I'm going to SXMD Moni, I'm saying execute, no messages found. Why do we not have messages here? If you have the answer, perfect. The reason is this is local processing within the adapter engine. Remember when we were talking about why do we need local processing? The local processing will go directly only in the advanced adapter engine. Nothing's going to go into the integration engine, and that's why you don't find anything in SXMB underscore Moni. Instead, you need to now go into adapter engine, go to your monitoring screens here. Let's close all this. Let's go to PI home page, configuration and monitoring home, go to adapter engine and go to message monitor. Okay, go to adapter engine, get message monitor and say message status overview in the last 1 hour, and now you see BS file system 00, this is my ICO message, and one message was successfully processed. And then I'm going into communication channel monitor, and I should be able to see the status of my communication channels, and they should be successful as well. This is my receiver channel, and the message was processed. So the idea of, okay, let's click on this one success message and look at the detailed audit log. So in this case, if you see, there's just one message, and that got processed locally without being sent. So if you see within the audit log, the message mapping was executed within the integrated configuration, and the message was delivered through the integrated configuration. There was no need for going through the SXMB MONI. So this kind of objects are what is called integrated configuration. So let's do one more thing. Let's upload the file one more time. I'm going here, I'm uploading the file. I'm going into AL11. Sorry, here we go. I'm going into AL11. I see that the file is here. So let's see if it, let's wait for a minute. If you don't want to wait for a minute, if you're as impatient as I am, then let's go to file. Let's open this communication channel. In the communication channel monitoring. And then stop the channel and start your channel. So now that my channel is stopped and started, my file has disappeared here. I go to my file ICO, and you see the counter is incremented. So the idea of add counter that we used in the file adapter, in the receiver file adapter, is it enables you to write a running sequence of numbers to your file. Okay, so with this we saw what an integrated configuration is, and we shall see one more scenario as to how do we use integrated configuration. Let's look at one more scenario to use the integrated configuration, right? So let's look at, let's go back to a scenario. Let's look at the next scenario that we have built. We built a SOAP to RFC scenario, and we built a HTTP to RFC scenario, right? So let's look at redoing the SOAP to RFC scenario, but using an integrated configuration, right? So let's go back to our namespace, okay? So what did we do in the SOAP to RFC scenario? The first thing we did was we imported the RFC BAPI user get detail. Now let's deal with a new different RFC. The RFC that I'm going to use now is going to be called BAPI user existence check. It is basically going to just check whether the user exists or not. All right. So this is my ECC system. I'm going to go in user PI15. Okay, like we saw, importing of RFCs will take some time, so be patient, don't do an alt tab. And while that is happening, let's just summarize one more time what we are going to be doing. We are now going to be building a SOAP to RFC scenario. Now in the SOAP to RFC scenario, the first step that we typically do is, but this SOAP to RFC scenario is going to be built using an integrated configuration. Okay, the first thing in the ESR that we're going to be doing is import the RFC, and then we will define one service interface. It's going to be outbound synchronous, and then in the receiver in the integrated configuration, we are going to define an in the integration directory, you are going to define an integrated configuration. Okay, it's not going to be anything different from what we did, but just to see how the power of integrated configuration and how easy it is to build a scenario using integrated configuration. We will look at building this new SOAP to RFC scenario. If you see, I'm still been talking and the RFC is still loading, and if you noticed, I've not done any alt tabs. I've just been patiently waiting for the RFCs to load. This is something that takes pretty much a long time in all servers, so always be patient. Do not lose patience when you're doing this step. I shall be back soon. Okay, so my BAPIs are available. Okay, so my BAPIs are available, so I'm going to now check BAPI user existence underscore check. Okay, I'm going to go ahead, select this BAPI, say continue, finish, and my BAPI is going to be imported. Let's wait for this to do its work. Finish, import successful. Now let's go ahead and create a namespace, right? Remember, we always create a namespace for each scenario. So So I'm going to call it training.com SOAP to RFC underscore ICO underscore 00, right? And I'm going to say define this as namespace for SOAP to RFC scenario using integrated configuration, and save your namespace. Okay, so my namespace has been created. It's out here, SOAP to RFC. So in the SOAP to RFC, the first thing that we will be defining is our service interface. So I'm going to say call the service interface SIOS SOAP to RFC underscore ICO underscore 00. Okay, it's going to be an outbound synchronous service interface because it is of request reply, and my request message is going to be my BAPI's request message. So I say apply, yes, and my response message is going to be my BAPI's response message. I say yes, excellent, and I save my message interface. Okay, next I'm going to define a message mapping, right? I'm going into mapping objects, underscore BAPI request, underscore SOAP to RFC underscore ICO underscore request. Okay, this is my request mapping, which means my source structure is my request BAPI structure and my response structure is my request BAPI structure. Okay, and here my input is just a username and I'm mapping my username to my username. Next, I'm going to create one more mapping, underscore BAPI, SOAP to RFC ICO response. So this is going to be our response mapping. So what is my response? It's BAPI user existence check, drag and drop, and select the response here. Okay, same way, grab BAPI user request check, drag and drop this guy here. Okay, now I'm going to just say click on this button, map identical field if names are successful, and all the fields will get mapped automatically. Okay, and then you're done. Now the last step in the ESR is to define an operation mapping. Right click, new, mapping objects, operation mapping, OM SOAP to RFC underscore ICO is what we're going to call it. Okay, my source server interface is going to be SIOS, my outbound synchronous service interface. My target interface is going to be my BAPI itself, so I'm dragging it, dropping it, and then I say read operations. It's asking me for my request mapping. I select my request mapping. It asks me for my response mapping. I select for my response mapping and I save my operation mapping. I'm going a little fast because this is stuff that we looked at in scenario 2 as well, and this is nothing new. It is just that this is repeating, so I'm going a little fast. When you're doing it, obviously it might take you a little more time than what I do, but do not worry, you can just pause the video and do it as it goes along. Okay, and I'm now right clicking and activating my changes. Okay, perfect. Now let's go to the integration directory. I'm going to create a folder called create, call it SOAP to RFC underscore ICO underscore 00. Alright, so the first thing that we will be doing is defining a sender communication channel. So my sender system is BS underscore file system underscore 00, and my sender communication channel is SOAP to RFC underscore ICO underscore SOAP underscore sender underscore 00. The naming convention typically we've been using so far. What is the scenario? What is the type of the adapter? What is the direction of the adapter, right? So create. Select the adapter type, make it as SOAP. Make sure that the quality of service is adapter type is sender and the quality of service is best effort. Okay. What's the next step? We define a receiver RFC adapter. Now, in the case of receiver RFC adapter, there's a concept of reusability. What I mean by reusability is the same receiver adapter can be used in multiple scenarios. In the case of sender adapters, you do not have reusability. Each sender adapter has to continuously be redefined for the adapter type. There are certain exceptions, but the rule of the thumb, excepting for those exceptions, is that sender channels have to be recreated for every scenario that you build, whereas the receiver channels can be reused. So in this case, to show you the concept of reusability, what I'm going to do is I'm going to my SOAP to RFC scenario. I already have a receiver RFC adapter. I'm going to reuse that adapter. So I'm not going to create any receiver channel. I've just created a center channel, and I'm going to go in and create my next object. And because we are dealing with integrated configuration, the object type I'll be creating is integrated configuration. Okay, I'll select DS file system 00 as my sender scenario, and here I'm selecting SOAP to RFC ICO 00. Okay, once I select that, I go ahead and say create. In the inbound processing, it will ask me for my sender channel. And what is my sender channel, everybody? My sender channel is my SOAP sender channel. So SOAP to RFC ICO SOAP sender 00. What is my receiver system? My receiver system is going to be my ECC system, right? So it is EH5CLNT 800. So select the EH5CLNT 800 system and say apply. And now we go into the receiver interfaces tab. So this was my sender agreement. This was my receiver determination. My receiver interface is my interface determination, equivalent to my interface determination. So I'm going to go in here and select my operation mapping. My operation mapping is visible. I select it. And in the outbound processing is equivalent to the, what is it equivalent to? It is equivalent to your receiver agreement. So here I go in and select the communication channel. And remember, I told you we will not be creating a new RFC adapter. We are going to reuse our RFC adapter. So the RFC adapter SOAP to RFC, RFC underscore receiver. The RFC that we use in the SOAP to RFC scenario, we will reuse in our integrated configuration. Okay, so I've just made reuse of that object, and now I'm saving my integrated configuration. With this, my configuration is done. I'm going to my change list, and I'm going to activate my changes. Okay, all we did was we created a SOAP sender channel, and we created one integrated configuration. So let's go ahead and activate our objects. My object has been activated. Now, if you remember our SOAP to RFC scenario, what did we do? We did display WSDL in the sender agreement. So how do we get the WSDL in the case of an integrated configuration? Go to the integrated configuration tab. Here again you will have a display WSDL. Select the WSDL, get the WSDL URL, copy the URL, and let's launch SOAP UI, right? So I'm launching SOAP UI. Let's wait for SOAP UI to load. You can always save the WSDL as well. Now I'm going to go ahead, create a new SOAP project. I'm going to call it SOAP to RFC underscore 00. In the WSDL, I'm giving the WSDL and I'm saying OK, right? It's going to ask me for my username. I give my username. Again, I've given the wrong password. So I'm going to say again one more time. Now it's perfectly loaded my user. I go into the request one, and now I see that I am ready. So in the username field, I'm going to go ahead and give my user. I say user PI15, and if I execute directly, will it work? It will not work. Why? Because I have not provided my authentication. So go into the authentication tab, say add new authorization basic, and say provide your username and your password here. And now I'm going to go ahead and execute. Perfect, and you got an immediate response that tells user PI exists. And did you notice the response was near immediate? Whereas in the case of the SOAP to RFC scenario, which we can re-execute one more time, you will see that the response takes some time. It takes 1, 2, you can count it. Let's do it one more time. 1, 2 seconds, right? Let's look at this. That's it. Even less than before I can count 1. Let's delete it. I say execute. It's done. This is the beauty of local processing within PI. The processing happens extremely fast. You saw the difference. 2 seconds to even before I could say 1. Right? This is why you use integrated configurations. Now let's change the username. User does not exist. Let's go to SXMD Mooney. Do we see the message? We see the message, but This is the message that we just triggered for the SOAP to RFC scenario, but we do not see the request for the integrated configuration. And that's why you do not find any message here. How do I monitor this message? I go into message monitor. I close everything here first. I go to configuration and monitoring home. I go into adapter engine. I go to message monitor. I go into message overview. And here if you see, okay, let's actually go to database. At times this refresh takes some time. And here I say EH5, okay, sorry. Let's look at it here. Yes, BS file system 00. This is our file to file scenario, so we should refresh it. What happens at times is the message overview does not show immediately. So if you go into the database view, you should be able to see your message. So if you see here, this was the message that we triggered, the API user existence check, and then the response that came back. Okay. So what did we learn in this session? We learned the beauty of local message processing and the fact that local message processing happens via integrated configuration. The previous exercises that we did had classical configuration where the messages would get processed via the adapter engine and the integration engine. And to do a classical message processing, you used to define sender agreement, receiver determination, interface determination, and receiver agreement objects. Now, in the case of advanced adapter engine, the processing of your message happens locally within PI, and for that locally within your adapter engine, and for that you create an object of type called integrated configuration. Okay, and how does an integrated configuration look like? Your integrated configuration has an inbound processing tab where you give the sender adapter. This is equivalent to your sender agreement. It has a receiver tab where you give the receiver business system or business component. It is equivalent to your receiver determination. The receiver interfaces tab, you define your mapping, and this is equivalent to the interface determination. And then in the outbound processing, you define what the receiver adapter is. And the last but not the least, we also checked how a receiver adapter can be reused by in our ICO scenario. We reused the RFC receiver adapter, so that we also looked at the concept of reusability. Okay, with this we come to an end to this session. We shall see you soon again in the next session.